So we talked about those dilutions last hour. Couple of things that I want to just recap a little bit, and that was using them for the testing. So let's say that we have, again, a meter that has a capacity or capable of reading up to 800 milligrams per deciliter. And again, we do a test, we do a sample. Our first test, it exceeds the capacity of the meter. Now, there are reasons. We talked a little bit right at the end of last hour about using as small of a dilution as possible, because the larger the dilution, the larger the increase in the potential error of that reading is. But there's reasons why we want to make sure we dilute it enough that we get within the meter's capacity. Main reason is you don't want to have to go back to a patient and take a second blood sample if you use up all your blood and you still haven't done it. So anyway, let's say that we have 10 milliliters of blood left to test. So we are going to attempt 1 and 2 dilution. First of all, we're going to use 5 milliliters of blood. So we're going to use half the sample so that we have extra. A 1 and 2 dilution, of course that's 1 and 2 ratio of serum to total. What's that give us as a ratio of serum to saline? Well, still 1 part serum. How many parts saline? 1. Okay. 2 total parts. 1 of them serum. The other 1 is saline. So that makes this pretty easy. If we're using 5 milliliters of blood, we're going to use 5 milliliters of saline. Let's say it's still off the meter. So we got 5 more milliliters. Let's attempt 1 and 4 dilution. So again, the 1 is the serum, the 4 is the total solution, which gives us a serum to saline ratio of what? 1 in 3, perfect. So we have 5 milliliters of blood left. How many milliliters of saline are we going to use? Well, 3 times 5 divided by 1 is 15 milliliters. So we're adding 15 milliliters of saline to the 5 milliliters of blood. So our reading is 404 milligrams per deciliter. So what is the true level of the blood here? Well, what was our final dilution that we used? 1 and 4. Where's the 404 go? On top. 404 milligrams per deciliter. And we cross multiply and divide. 404, or 4 times 404 divided by 1 is 1,616 milligrams per deciliter. That is dangerous no matter who you are. Okay. Little review for you in your notes. And a 2 and 9 dilution. Find a ratio of serum to saline, and B, the ratio of saline to total solution. So the 2 and 9 dilution, the 2 represents the serum, the 9 represents the total solution. So what's the ratio of serum to saline going to be? 2 to 7. Very good. And that looks like a 7. There. What's our solution of saline to total going to be? 7 to 9. Very good. Any questions on those? Okay. So next, what we're going to look at we are going to use 40 milliliters of 64% solution. In a 3 and 8 dilution. Find the new concentration. So here what we're using now, rather than using a pure medicine, a pure medication of some sort, we're using a concentrated form of solution, and we're diluting it down to get a less concentrated solution. So the 3 and 8 here, the 3 represents the concentrate again, which is the 64%, and the 8 represents the total solution again. So, if we're using 40 milliliters of the 64%, how much total solution are we going to get after the 3 and 8 dilution? So come up, be kind of ugly. 8 times 40, come on, there we go. 8 times 40 is 320 milliliters. Divided by 3 is going to be 106.67 milliliters. So we now have, after a 3 and 8 dilution, we now have 106.67 milliliters of this new solution. Problem is, what percent is it? Well, did we add any medication to this? No, in a definition of dilution, all we're adding is some sort of a neutral solution, sterile water usually. So we've not added any medication. So the same medication that's in the 40 milliliters of 64% has to be in the 106.67 milliliters of whatever percent that is, correct? So 40 milliliters times 64%. 64% of 40 milliliters is how much? Gives us 25.6 milliliters of medication. So 64 milliliters of a 40%, or 40 milliliters of a 64% concentration can contain 25.6 milliliters of whatever that medication was. So now we use whatever this was, blank percent, blank over 100, equals 25.6 milliliters out of 106.67 milliliters. So 25.6, if we're going to cross multiply and divide, 25.6 times 100 divided by 106.67. So times 100 divided by 106.67, 23.999 or 24%. So our new solution is at 24%. Interesting thing occurs here. If we compare the new concentration to the old concentration. New concentration is the 24%. What was the old concentration? 64%. Just like any other ratio, of course, the percent symbol divides out, cancels out. 24 and 64 can both be reduced by 8, which would give us 3 over 8. Does that look familiar? That's our dilution. It was a 3 and 8 dilution. In a 3 and 8 dilution, or in any dilution, the ratio of the new concentration to old concentration is the same as the dilution ratio. So let's say we will use a 2 and 7 dilution on a 56% solution. Find the new concentration. Find the new percent. So it's a 2 and 7 dilution. Now it's being diluted, which means the concentration is going to be lowered. We're going to decrease the concentration. So the 56% is the old concentration. The new one's going to be smaller. So the new concentration is going to go on top. So that old concentration of 56% has to go on bottom with the 7. So we will cross multiply and divide. 2 times 56 divided by 7 will give us, what does that come up to, 16? So the new concentration is 16%. Let's say after a 3 and 5 dilution, the new concentration is 36%. Find the old concentration. So 3 and 5 dilution. So 3 over 5. If you haven't noticed the pattern yet, the new concentration always goes on top. The old one always goes on bottom, because the old one will always be larger than the new one. 36 is going to go top or bottom. Top, that's the new concentration. So we will now cross multiply and divide to get the percent on bottom. 5 times 36 is 180. Divided by 3 is 60%. So the old concentration had to be 60%. What dilution do you need to use to reduce 48% solution to 9%? This is a little different than what we've done before, but remember, we have our dilution ratio. It's going to equal our percent, which is going to be our new percent, over our old percent. New concentration over old concentration. So we can go ahead and just put 9% on top, 48% on bottom, and just go about reducing this. The percents will cancel out. 9 and 48 can both be divided by 3. 9 divided by 3 is 3. 48 divided by 3 is 16. So this is a 3 and 16 dilution. So let's get a bit more complicated. You guys haven't figured it out yet. I like to make things worse. How much saline do you need to add to 60 milliliters of 36% solution in order to dilute it to, what do I do there? Let's take it down to 12%. So our first thing we want to do is we want to find the actual dilution. The dilution is going to be found by doing a ratio of the concentrations. What's that ratio going to be? What's going to go on top? 12% over 36%. Percents cancel out. Both of those can be reduced by 12. Gives me a 1 in 3 dilution. So now in a dilution, remember that 1 is the amount of concentrate, or the serum, and the 3 is the total volume. Do we want the ratio of concentrate to total volume? Do we have the concentrate? We have the amount of the higher concentrated solution. But are we looking for the total volume? No. We're looking for the saline. So we're going to adjust this to give a ratio of 1 to 2, which is going to be the concentrate to the saline. So we have 60 milliliters of the concentrated solution. Cross multiply and divide. 2 times 60 divided by 1 is going to be 120 milliliters of saline. One for you to try in your notes. You know those mixture problems that were such a problem for us a few weeks ago? Well, let's look at this. How much (72% solution) and how much NS do you need to mix to get, what do I want to do here? 1,400 milliliters of 12% solution. Try that in your notes quick. See what you come out to. Okay, so first step. Our dilution. Using the concentrations. So it's 12% over 72%. which will reduce to 1 and 6. Very good. Of course, the 1 represents the amount of the concentrate. The 6 is the total solution. We have 1,400 milliliters of total solution. If we cross multiply and divide, 1 times 1,400 divided by 6, it's going to give us an ugly number, but, oops, 233.33 milliliters. That is of the 72%. That is the concentrated solution. So 233 1/3 milliliters of 72%. Now to find the amount of saline required, we're going to use a 5 and 6 ratio. You guys remember where that comes from? That is the saline to total solution. So once again, 1,400 milliliters of total solution. Cross multiply and divide. 5 times 1,400 divided by 6 is 1,166.67 milliliters of saline. How many of you came up with those? No? Half of it? You got the 233? Or you just got the dilution? Okay, well, that's a start. Now, as we saw earlier, our very first example, we had the, let's say we're going to use 20 milliliters of a 60% solution in a 1 in 5 dilution. And we wanted to find, this is where we wanted to find the percent of the diluted solution. So we had the 1 in 5 dilution, and we used that to find, okay, 20 milliliters, cross multiply and divide, there's going to be 100 milliliters of the new solution. We said the amount of medication in the 20 milliliters of 60% had to be the same as the amount of medication in the 100 milliliters of whatever that new percent was. Because of that, I can use 20 milliliters times 60% has to equal 100 milliliters times whatever that new percent is. Does that make sense? Because both of those represent the amount of medication. So if we're dealing with a case like this where we are adjusting the concentration of a solution, we talked about this a little bit when we were doing our mixture problems of the amount of a material in that solution was equal to the concentration times the volume, right? It's the exact same thing here. The amount is the concentration times the volume has to be equal before and after. So the concentration before times the volume before has to equal the concentration after times the volume after. The little 1s and 2s here are not numbers. And really, 1 and 2 are numbers last time I checked. In this case, all they are indicating is that this C is different from this C. This is a concentration before, this is a concentration after, or a second. This is the first concentration, this is the second concentration. Same with the V's. This is the first volume, this is the second volume. So the 2 is indicating that this volume is different from this volume. It's also indicating that this volume is related to that concentration. So back to that problem here, 20 milliliters of 60% solution. In a 1 in 5 dilution. Well, the new concentration, of course, now we know that we can just use the dilution ratio. The 60% is going to go on bottom. You're going to cross multiply and divide, and you'll get 12% here. But what if we had done it, given you a little bit different information? Let's say we're going to use 20 milliliters of 60% solution and dilute it to a total volume of 100 milliliters, which is the total volume we got up there before when we were figuring out what the dilution. So now 20 milliliters and 60% are our initial concentration and volume. Now I said C1 times V1. You could change the order. Just to multiply them together, you could do concentration times volume, volume times concentration. Really doesn't matter. It also doesn't matter whether I write this as 60 or 0.6. I can do it as a rate or as a percent. As long as I do the same on the other side. So my concentration of 60% times my volume of 20. I'm going to leave the milliliters off just to simplify this. I know it's going to be milliliters on the other side. I'm looking for the concentration there, so that's C2 times my volume of 100 milliliters. So to solve this, 60 times 20 is 1200 equals C2 times 100. How am I going to solve that for C2? Divide by 100. C2 is 12. Remember, C2 is a concentration. The concentration here, C1 was given as a percent, that's 60%. This is a percent, 12%. So the concentration of the new solution is 12%. So if we use 30 milliliters of (75% solution to create, what do I want to put in here? 150 milliliters of a dilution. Find the new concentration. Find the new percent. I'll try that in your notes quick. See if you can make that work. We'll go over it in a second. So again, it doesn't matter whether you do volume times concentration or concentration times volume, same difference. So we've got 30 milliliters times 75% equals, on the other side, of 150 milliliters times whatever that percent is, C2. I'm going to multiply. 30 times 75 is 2,250 equals 150 times C2. And we will divide by 150. Comes up to what, 15? So that is 15% is our new concentration. Okay, next, let's take a look at this one. If I have with 150 milliliters of 27% solution, how much 9% solution can you create or can you make? Well, it's the same concept. We have volume times concentration, so we have 150 milliliters goes with the 27% equals the 9%. So this is going to be our volume 2 here times 9. $150 times 27. 4,050 equals V2 times 9. And of course, we're going to solve that by dividing by 9. Which is going to give us, what, 450? Is my volume. So that is 450, what units were on the 150? Milliliters, so this is also milliliters. So that'll make 450 milliliters of the 9% solution. So how much 12% solution can be made from 360 milliliters of 30% solution? Try that one in your notes. Okay, so what's the original volume and concentration? 360 and 30. So 360 times 30. New volume and concentration. We don't know the volume. Concentration is 12. So 360 times 30 is 1,080. V2 times 12, so we're going to solve by dividing by 12, which is going to be what? What is it? 900. There we go. I did something wrong there, didn't I?
Yeah, you did good. It's 10,800.
10,800, okay. I lost a zero. I was going to say, something doesn't look right there. 10,800 is what that multiplies out to be. Thank you. So yes, the new volume is 900, so it's 900 milliliters of the 30%. A little bit different approach. How much saline and how much 36% solution are needed to create plan this out so I know it actually works. 240 milliliters of 9% solution. So again, we have 36% solution. We're going to end up with 240 milliliters of 9%. So that's going to be our ending amount. At the beginning, we have the 36% solution, and we're looking for the volume. So 240 times 9 is what? 2,160? Does that look right? So then to solve, we divide by 36. Get that the volume equals 60. So that is 60 milliliters of the 36%. Are we done? Why aren't we done? How much normal saline do? So if we have 60 milliliters of 36%, there's going to be 240 milliliters of 9%. The difference has to be made up with saline. So 240 milliliters minus 60 milliliters gives us 180 milliliters of saline. So in your notes, quick. How much saline do you need to add to to 400 milliliters of 72% solution to create 18% solution. So find that one in your notes for me quick. Okay, so we have 400 milliliters of 72%. So 400 times 72. We don't know how many milliliters we're going to have of the 18%. So the percent on there. So we're going to multiply and divide. 400 times 72 divided by 18 is going to give us 1,600 milliliters of the 18%. How many have you got to that point? Perfect. So then how much saline do we need? Well, of that 1,600 milliliters, 400 milliliters is the 72%. We subtract the other 1,200 milliliters must be saline. Any questions? Okay. Well, some homework for you guys to try over the next week. In your book, page 130 to 132, 1 through 37. If you just want to work on the odds, that should be good enough for those. Those were the dilutions. Page 134, 1 through 11, the odds. And page 138, 1 through 17, the odds. Those last two pages both deal with adjusting the concentration or changing the concentration of a solution. One is using dilutions to do it. The other is using that concentration adjustment formula, the C1V1 equals C2V2 that we just went over. Remember, you can still do corrections on that second test that you got back. Any of you at the other sites, if you didn't get your test back yet, send me an email and I will send it right back to you. If for some reason you can't see my inking on your test, you can't see which ones are marked wrong, let me know and I'll send you a message telling you which ones were wrong. Otherwise, you guys have a great weekend. We'll see you next Friday.